to everyone and welcome once more to another video in our YouTube channel. So in this video we are going to be looking at the topic partial fraction, and we are going to be solving a very trickish partial fraction equation which majority of the students could not handle the equation. Now you might think the topic is very easy, but then when I display the equation, pause the video, solve the equation, select your answer, and then now you play the video back to see if your response was correct as well as your steps. Alright, so here's the equation. We are asked to partial fract the fraction x plus 1 divided by x plus 3, all that raised to the power 20, and we have responses. The first response is it is 1 over x plus 3 to the power 19 minus 2 over x plus 3 raised to the power 20. B, 2 over x plus 3 raised to the power 19 plus 2 over x plus 3 raised to the power 20. C, 2 over x plus 3 raised to the power 19 plus 3 over x plus 3 raised to the power 20. And finally D, 2 over x plus 3 raised to the power 19 minus 3 over x plus 3 raised to the power 20. Alright, so let's dive straight away into the solution. But before getting into that, a very smart student can already figure out the answer even without solving. All you need to do is you just need to look for the LCM of these various fractions, and then you try to subtract the two fractions, right, to see if it gives you the original fraction. And doing that, clearly you see that the response is going to be A, because the LCM here is x raised to the power x plus 3 raised to the power 20. Where you divide with x plus 3 raised to the power 19, you get x plus 3. Where you divide with x plus 3 raised to the power 20, you get 1. So you're finally going to get x plus 3 minus 2, which will give you x plus 1. So that is going to be the answer. But have you ever thought of maybe being in an examination condition? Let's say you're actually doing paper 2 and you've been asked to integrate this function by partial fractions, meaning you need to partial fract this first before integrating. That's now the equation, because if it's an MCQ, you don't need to show your workings, so you can use any method you want. But now if it is a structural equation, if it is a structural equation where you're actually supposed to show your workings, how you arrived at the final answer, what are you going to do? Alright, so I came up with a very interesting method that will help you to solve problems like this. Alright, so firstly, this is what I'm going to do. I'm going to look at the numerator of my function, and then I look at the denominator. Now what I do is that I try to write the numerator as my denominator. That's I try to write my denominator to look like the numerator, and then now multiplied by another function. So the numerator is x plus 1 and the denominator is x plus 3, all that raised to the power 20. Now in the denominator, x plus 3 is a factor, so I can write x plus 3 raised to the power 20 as x plus 3 times x plus 3 raised to the power 19. And since my numerator, I'm writing like that because I can see that my numerator is a linear factor, my denominator as well, I need to extract a linear factor from it, and then I get this, and then from here now I can easily partial fract what you can see here, and then later on I multiply it with 1 over x plus 3, all that raised to the power 19. Alright, so doing that, I can now partial fract this function here, x plus 1 divided by x plus 3. Since you can see that they have the degree of the numerator is the same as the degree of the denominator, which is 1, you first of all do long division before partial fracting. But now you can also skip the long division step in cases like this because it is easily seen. Why? Because we just try to make the numerator to look like the denominator, meaning that we need a certain x plus 3 to appear in the numerator, such that whenever you carry out the final operations, you're still going to arrive back at x plus 1. It is your decision to also do long division here, but now we can skip that step by simply doing this, making the numerator to look like the denominator. You see that the denominator is x plus 3 and the numerator is x plus 1. If I want to have an x plus 3 in the numerator, then I'm just going to write the x plus 3 there. Then now I try to do something with the x plus 3 that is going to give me back x plus 1. So when I write x plus 3, I have already had what is in the denominator. Now the numerator is actually x plus 1. It means that I need to subtract 2 from the x plus 3. I'm going to get back at x plus 1. Now what I do is that I pair now the fractions together. So I'm going to rewrite this as x plus 3 as a term divided by x plus 3, then minus 2 divided by x plus 3 is the same thing. Why? Because they have the same denominator, so I can just subtract the numerators and I get back to this step above. Alright, so x plus 3 divided by x plus 3 is 1, then minus 2 divided by x plus 3. So even if you did long division, like you took x plus 1 divided by x plus 3, you're going to arrive at 1 minus 2 divided by x plus 3. Now this time around, I can now send in our 1 divided by x plus 3 raised to the power 19. Alright, so doing that, I'll have 1 times this here. Remember that 1 over x plus 3 raised to the power 19 is the same as 1 all divided by x plus 3 raised to the power 19 is the same thing. So when I multiply with 1, I get this, and then minus 2. I'll now multiply x plus 3 times x plus 3 raised to the power 19. Since they have the same basis, I just add the powers. It gives me x plus 3 raised to the power 20. And finally, the correct response is A. Alright guys, so this is what I wanted to show you guys. So you can try that. I'm going to put equation in the comment section so that you try it. I'm going to also put the responses. Actually, I'm going to put it in the community tab of this YouTube channel so that you can actually see the responses clearly, and then you solve and then you pick your answer. Alright, those who have not subscribed to the channel, please endeavor to subscribe to the channel. Also turn on your notifications so that whenever videos have been uploaded, you always be notified to come and watch. So see you in the next video, and thanks for watching.